Okay, this is chapter 8 and question 8. And we have a baseball that is 0.145 kilograms in mass. Draw a little picture here. It's pitched towards the batter. It's a great picture. At 45 meters per second towards the batter, and the batter hits it at 55 meters per second in the opposite direction. We are trying to figure out if the velocity, find the magnitude of the change in momentum of the ball and of the impulse applied to it by the bat. So we have delta P for the change in momentum. That's going to be equal to m times delta V, and we have two velocities here, so that's going to be equal to m times our final velocity, which is V2 minus our initial velocity V1. And I'll just plug that in here. It's going to be 0.145, which is our mass, times negative 55 minus 45. Show that. So we have 0.145 times negative 55 minus 45. And that comes out to negative 14.5 kilograms meters per second. Let's get that right. Okay. That's really bad. Negative 14.5 kilograms meters per second. For B, part B, so that's the first part, that's part A. For part B, if the ball remains in contact with the bat for 2 milliseconds, find the magnitude of the average force applied by the bat. Oh, I'm sorry, so negative 14.5 kilogram meters per second is both the magnitude of the change in momentum and the impulse applied to the ball. They're going to be the same. So for part B, it just wants to know if the bat's in contact with the ball for 2 milliseconds, what's the magnitude of the average force applied by the bat. So that, we're going to use an equation J equals F delta T. Let's show that. We're going to use F equals J, or J equals F delta T. Delta T, let's figure that out, is equal to our time that we're in contact with the ball times, we're just going to convert delta T to seconds instead of milliseconds. So delta T is actually going to be equal to 0.002 seconds. Then we're going to solve for this equation here. We're going to solve for F. So F equals J over delta T, which is negative 14.5. That's what we got before. Over our time. Can't tell where. So negative 14.5 over 0.002 seconds. And that comes out to our final answer, which is negative 7,250 newtons. Negative 7,250 newtons is our final answer. That is the force, the average force. How'd they word it? The magnitude of the average force applied by the bat. Is that? And I believe it's negative because it's just in the point of perspective that we're hitting it in a negative direction, I think. But anyway, that's all.